Hi there, in this video I'm going to go through and summarise the integration methods that we've seen so far. So we went through these methods, the four methods, in the videos that I've done. So I've provided links to all of these methods in the description below. The first method that we've seen is substitution. So on the left hand side, right at the top, substitution, involving cases involving exponential functions. And remember the idea of substitution. When applying substitution, we generally took u to be the term involving the power. Okay, so forget about the power, take u to be the term involving that power, and for exponential substitution we took our substitution to be the power. Okay, so whatever the power of the exponential function is, we take our substitution for u to be that term. Okay, the second method is integration by parts, and remember we also seen cases where our function contains either a natural logarithmic ln term or an inverse trigonometric function. Okay, and I stress that if you have a special case, so the special case is any integral containing a natural logarithmic or an inverse trigonometric function, always take u to be that term. So take u to be the natural logarithmic function, or take u to be the inverse trigonometric function when applying by parts, and dv over dx then will be the remaining term. And if it's not a special case, take u to be the x term and dv over dx to be the remaining term. Okay. Also, I created a video on integration by parts, so if you haven't seen that video, a link to the integration by parts video is provided in the description below. Okay. The third method that we've seen is the integration using the f primed over f results. So remember the result, whenever you integrate a function of the form f primed x over f of x, the result being ln of the modulus of f of x plus c. Okay, now we use this result to integrate fractions. Another result used to integrate fractions is method 4, so bottom left hand side, partial fractions. Okay, so again, when integrating fractions, at some stage when using partial fractions, when using that approach, you may need to use the integration of f primed over f of x, or you may need to use the integration of ax plus b to the power of n when applying the partial fractions approach. Okay, so methods 3 and 4 we use when integrating fractions. Methods 1 and 2 we use when integrating non-fractions generally. Okay, now in my next screenshot, okay, I've made the flowchart, and this may help you when it comes to integrating functions. Okay, so this generally works. Okay, so the question that you need to ask yourself is the integration standard? So is it a standard integral? If the answer is yes, then use the standard integration result or the standard related result. And if the answer is no, the next question that you need to ask yourself is, are you integrating a fraction? So if you're not integrating a fraction, if the answer is no, check method 1. So if you go to the previous screenshot, method 1 is substitution. Okay, so check substitution. And if you go to the next screenshot, so if method 1 fails, then it's most likely to be method 2. So if you go to the previous screenshot again, method 2 is integration by parts. Okay. Now, if you are integrating a fraction, check method 3. Now, if you go to the previous screenshot, method 3 is the method involving the integration of f primed x over f of x. Okay? And if that method doesn't work, so if method 3 doesn't work, it's most likely to be method 4. So if you go to the previous screenshot again, method 4 is partial fractions. Okay? And if method 4 doesn't work, you may need to use algebraic division as you may be integrating an improper fraction. So what I'm trying to say is partial fractions is used for proper fractions. However, if your fraction is not proper, so if your fraction is improper, you're going to have to use algebraic division first and then integrate that result later. Okay? Now, at the bottom of this flowchart, trigonometric integrals. And remember, in my trigonometric integration video, and once again I'll provide a link to that video in the description below, so all of the integration methods 1 to 4, the links to all those videos are in the description below. So trigonometric integrals, so to integrate cos squared or sine squared, remember the idea, you need to use a double angle formula for cos. And point number two is, if you want to integrate tan squared or cot squared of an angle, then you'll need to use the trigonometric identities before you actually integrate. So if you want to integrate tan squared of an angle, you need to use the identity 1 plus tan squared x equals sec squared x. However, if you wanted to integrate cot squared of an angle, you need to use the identity 1 plus cot squared of an angle equals cosec squared of the angle. Okay? Now, let's test this idea. So let's test these principles with some examples. So back to the paper and pen. Now, here is example number 1. So we need to integrate 3x squared into x cubed plus 1 to the power of 5. Okay, so let's go back to the flow diagram in particular. Now, we need to ask ourselves firstly, is the integral standard? Now, the answer is no. Okay, so in this case, are we integrating a fraction? That's our next question we need to ask ourselves. The answer is no again. And remember the idea, check method 1. So if you go to that previous screenshot, method 1 is substitution. And remember the idea of substitution, choose u to be the term containing the power. So let's go back to this example. So we're integrating 3x squared into x cubed plus 1 to the power 5. So I'm going to try substitution. So I'm going to take u to be the term involving the power. So the power here is 5. Okay. So I'm going to take u to be x cubed plus 1. So du by dx, when I differentiate, we're going to have 3x squared. Okay. So 3x squared, the du over dx term, is related to the terms remaining. So substitution is going to work. So let me continue substitution. So du is 3x squared dx. And this is where I like to stop and think. So in this case, let's take my green pen. The 3x squared dx, so this term as a whole, we're going to replace that by du. And the x cubed plus 1 is replaced by u. Okay, so substitution is working for us. So by substitution, so let's rewrite this integral. So in this case, 3x squared dx, as we discussed, is replaced by du. So let's check those terms. So we replace those terms. And x cubed plus 1 is replaced by u to the power 5. Okay? So if we integrate u to the 5 with respect to u, it's u to the 6 over 6 plus c. And since u, our substitution, is x cubed plus 1, and when you replace in this answer, your answer is going to be 1 over 6 u, which is x cubed plus 1, to the power of 6 plus c. Okay, so that is your solution to example 1. Okay, so let's integrate ln x with respect to x. So back to our screenshot. So here's our flow diagram screenshot. So Is the integral standard? The first question. Answer is no. Okay. Are we integrating a fraction? Answer is no again. Check method 1. So remember in the first prepared screenshot, method 1 is substitution. Substitution is not going to work for ln, okay? So it's not going to work for ln x only. So it's going to be method 2. Method 2, we're going to try integration by parts. And remember the special case, if you're integrating a term involving ln or an inverse trig function, take u to be that term. So our term involves ln x. Let me take u to be ln x. dv over dx then will be the remaining term. Okay, so back to the paper and pen. So let's try by parts. So remember the formula. Integration of u dv over dx with respect to x, that's uv, minus integration of v du by dx with respect to x. So since it's a special case, since I have ln in my integral, I'm going to take u to be ln x, dv over dx then. So dv over dx is the remaining term, so I could rewrite ln x as 1 times ln x. So since I'm taking u to be ln x, dv over dx is 1, the remaining term. Okay. So for by parts, I need du over dx as well as v. So du by dx, when I differentiate, it's 1 over x. V on the other hand, when I integrate 1 with respect to x, answer is x. Okay. Remember, do not add c when working out v. We'll add c at the final stage. Okay. So if I replace the results in our formula, left hand side is the integration of u, which is ln x. dv over dx is 1. So the left hand side should match the question. Okay. And that is equal to u, which is ln x, v, which is x, minus integration of v, which is x, du over dx, which is 1 over x. Okay. Now, as I said in my integration by parts video, don't integrate the right-hand term straight away. Multiply the brackets and simplify, and then integrate. So if I expand and simplify, we're going to have x ln x minus the integration of. These two x's will cancel, so we're integrating 1. So the answer is x ln x minus integration of 1, that is x plus c. So this is the solution to example 2. Let's integrate 2 sine squared 4x with respect to x. So back to the flow diagram screenshot. So in this case we have one trigonometric term to integrate. So if we look at our trigonometric results over here at the bottom of our flow diagram, remember what I said. To integrate cos squared or sine squared of an angle, you need to use a double angle formula for cos. So since we have sine squared inside our integral, we're going to be using the formula cos 2x equals 1 minus 2 sine squared x. Okay, so back to the paper and pen. So when we rearrange 2 sine squared x, that is 1 minus cos 2x. So if we look at our integral that we have in the question, okay, I have the 2 here, so that's no problem. But I have sine squared 4x, okay? So remember, to get that 4 here, we just need to multiply the angles in our identity by 4. So to get the 4 here, just multiply the angles by 4. So if we multiply the angles by 4, we're going to have 2 sine squared 4 times x is 4x. That's equal to 1 minus cos, and 4 times 2x is 8x. So remember, to get the 4x as part of your angle in your identity, just multiply the angles only by 4s. Okay? So as a result, we can rewrite this integral as 1 minus cos 8x. So let's integrate that. So when I integrate 1, that is x. When I integrate cos, it's plus sine. So it's sine 8x divided by 8, and then add c. Okay? So if you're unfamiliar with trigonometric integrals, be sure to watch the video that I did on trigonometric integration. I'll provide a link to that video again in the description below. Okay? So that is how you would handle that integral, example 3. Example 4 is to integrate sec squared 2x over 4 plus 3 tan 2x. So back to the flow diagram screenshot. So the first question that we need to ask ourselves, is the integral standard? Answer is no. Second question, are we integrating a fraction? Answer is yes. Check method 3. And back to the first screenshot, method 3 is the integration of f primed x over f of x. So let's check that method first. So back to the paper and pen. So remember the method that I used in the integration of f primed over f of x video. So a link to that video is provided in the description below. Okay. So remember the method. F of x is the term in your denominator, that being 4 plus 3 tan 2 of x. Now we calculate f primed. So f primed means differentiate. So if we differentiate f of x, when I differentiate 4, that is 0. When I differentiate 3 tan 2x, you're going to get 3 sec squared 2x times 2. Okay? And when we simplify that, 3 times 2 is 6 sec squared 2x. Okay, so that is what we should have for f primed. So remember the idea, we need to rewrite this integral. So keep the denominator term as it is, so keep the 4 plus 3 tan 2x as it is. And remember, in that video, the f primed, so 6 sec squared 2x, keep that on the top, so green with green, so 6 sec squared 2x, copy that on the top. Now these two integrals, so the integral that you have in your question and the integral that you have currently, do not match. Okay, so to make them match, remember the next step. Outside your integration sign, the number here, so the number 6 here, copy here. So red with red, so number 6 with number 6. So only the number 6 right here. So remember, you can only write constants outside your integration sign. Okay? And this number, so the number in the numerator of your question, so the number 1 in the numerator, copy that on top here. So number, dotted black, dotted black. So 1 goes here. Okay? So then you do a double check. This integral should be the same as your integral that you have here in your question. 1 over 6 times 6 is 1. Okay, so we're all good so far. So the answer is 1 over 6. This integral is of the form f primed over f of x. So the answer is ln the modulus of f of x 4 plus 3 tan 2 of x plus c. So that is the solution to example 4. Okay.